Welcome everybody to the Enology webinar series. My name is Andrea Botazatu. I am an associate professor and Enology extension specialist with Texas A&M, Texas AgriLife Extension Services. And this webinar is part, as I mentioned, of my Enology webinar series. Today's topic is chest wine, and this is a chestnut-based product, enological product, and we are going to learn all about it. I was very intrigued when I first read about it. I found a post on LinkedIn, and that's how I learned about it. Very intrigued, and I'm looking forward to learning more. Today's presenters are Dr. Isabel Fernandes, and she is the R&D coordinator at Tree Flower Solution, where she leads product and process development. With over 20 years of research experience across multiple industrial sectors, her work spans polymer synthesis, micro and nanoencapsulation of natural extracts, and functionalization of food and cosmetic products. Her current focus is on enological processes and the development of innovative processing aids for winemaking. We also have Dr. Marcio Carruccio, who is an assistant researcher at the Polytechnic University of Bragança in Portugal and co-founder of Tree Flower Solutions, a biotech company developing sustainable technologies for the agri-food and wine sectors. His research centers on food science and natural product chemistry applied to enology. A highly cited scientist in the food field, he has authored over 90 scientific papers, 12 book chapters, and holds 3 patents. And with that, please take it away.
Thank you so much, Joanna, for the invitation, for being here today. So I'm just going to do a little overview of the chestnut flower and Tree Flower Solutions, and then I'll give all the scientific parts to our R&D coordinator, Isabel Fernandes. So, like I said, thank you so much for the invitation to be here. It's actually a privilege to be talking about our technology. So today we're going to speak about chest wine, a natural solution for wine protection. So an alternative to sulfites that is based on chestnut flowers and other residues of the chestnut tree. So Tree Flower Solutions is the company that sells chest wine. It is based in Bragança, in the northeast of Portugal, and its main focus is to market organic and natural extracts for the food and other industries. This is the team, well, the 4 shareholders of Tree Flower Solutions, myself, João, Philippe, and Jorge. We started Tree Flower Solutions back in 2020, and we have right now until today got 3 million euros in investments from those 3 investment companies. So next slide, Isabel, please. Okay, so like I said, Tree Flower Solutions started in 2020, but the research on chestnut flowers is much older. It actually started back in 2014 at Bragança Polytechnic University, where I work. We started researching these flowers a while ago, and we have been doing several essays on them. Next slide, please. So here are the first articles we published on chestnut flowers. We first tried to identify all the main compounds that could have bioactivity, phenolic compounds, some organic acids, among others. And then, of course, we focused our research on the bioactivities, namely the antioxidant activity, also the antimicrobial. And then we did test some tumor lines and also the cytotoxicity, which we proved we did not have any type of cytotoxicity. So due to having a very good antioxidant activity, we then thought that the chestnut flowers could be used as preservatives for foods. And we started testing it on some pastry that is very typical from this region of Portugal, and also on cheese. And we did get very interesting results in terms of avoiding oxidation of the cheeses and those pastries. And then we thought about how we could use it for other food types, and that's when we thought about chestnut flower for the preservation of wine. And the Polytechnic University of Bragança then filed a patent, which was granted, and then that patent was leased to Tree Flower Solutions, which has been improving the extract up till today, and is now selling chest wine, which is now called chest wine, and has been selling it all over the world. But now to learn a bit more about how our technology works and all the technical parts, I think I'll pass on to Isabel to take it from here. Thank you so much.
Okay. Thank you, Marcio. So good afternoon to everybody. Good morning in there. So what I'm going to speak about is how chef's wine works in the wine. But first, for us better to understand the different activities that chef's wine may have in the wine application context, we need to understand all the problematic of wine spoilage, understand the mechanisms involved in the wine degradation, look a little bit to the traditional preservatives that are usually added to preserve wine, and most of them are sulfites, and understand the context where chef's wine is framed according to the World Organization of Wine and Vine, OIV, in the class of oenological tannins, and then understand how chef's wine works, compare its role and its functionalities with sulfites. And then I'm going to explain a little bit how to use chef's wine and to show you some proofs of the concept in the real context of the application of chef's wine in wine. So the wine spoilage process involves three main mechanisms: the enzymatic, the chemical, and the microbial one. The enzymatic is related to the earth oxidation through the enzymes that comes from the microbial contamination of grapes, and that usually lead to the formation of brown polymers, provokes the phenolic content depletion, change the colors, and also impacts the of flavors formation through aldehydes formation. Looking to the chemical mechanism is mostly due to the presence of oxygen, and this oxidation occurs leading to ethanol oxidation, the formation of acetaldehyde, acetic acid formation, but together with other volatile compounds, also provokes the color modification and the generation of flavors. Regarding the microbial degradation, we have different type of microorganisms like bacteria, yeasts, and some fungi. All of them can generate off flavors. Biofilm formation can lead to turbidity, but the most worried is the toxicity that is related mostly with biogenic amines formation and mycotoxins. This is more related with the presence of filamentous fungi. And if we look further inside this type of degradation mechanisms, and particularly to the oxidation phenomena, we have the enzymatic pathway and the chemical pathway. The enzymatic pathway is related to the presence of specific enzymes that are polyphenol oxidases. They can convert monophenols, so short phenolic compounds, into monocatechol, and then in the presence of oxygen, they convert it into quinones that can further be converted in specific polymerization reactions that will lead to round polymers formation and the change of the color of the wine. In the chemical pathway, we have here a mechanism based specifically in reactions that are related with the presence of oxygen and metallic ions. And once oxygen in the presence of metallic ions generate active radicals, they start to attack the short phenolic compounds and lead to the formation of quinones. If this reaction goes on, it will lead to the formation of hydrogen peroxide and other related active radicals that will further oxidize the wine and will attack ethanol and lead to the formation of acetic acid. Specifically, we have Fenton reactions where we generate these type of hydroxyperoxyl radicals that are quite active, chemically active, that will start to attack the short phenolics and generate the presence of the production of hydrogen peroxide that will further move on the reaction chain leading to the several compounds formation, and that will lead to secondary amines, to the color modification, and to the acetic acid production. Looking closer to the enzymatic oxidation, enzymes are most of all proteins. And these enzymes, behind being proteins, they require specific conditions to process the phenolic compounds. This means we have a lock-key model where the enzyme assumes a specific conformation where, in order to lock the molecule that is the substrate, and to do the binding with the substrate, we need to have a cofactor. The cofactor are metallic ions. Specifically in the case of polyphenol oxidases like tyrosinase and lacases, we need copper ions to do this binding. After this, the enzymes start to degrade the monophenol to reach a quinone in the presence of oxygen. Looking closer to the microbial degradation, well, here we have a huge issue because we need microbes to produce wine, we need yeasts to do the alcoholic fermentation, we need bacteria when we are going to do the malolactic fermentation, but we have a plethora of microorganisms that can be present in wine that can convert different substrates and in products that most of them are unwanted, like secondary flavors, bitterness, the mousy flavor, the mannitol taint, and a huge group of molecules that will spoil the wine. But we also have those that we require, specifically the yeasts and the lactic acid like Oenological that are required for malolactic fermentation. So we need to control those that we don't require in the wine and favor the conditions for developing the ones that we need to produce our wine. And after this, what is the main strategy that wine producers use for controlling all the wine production, all the vinification process? Well, the state of the art is the application of sulfites. We have several other type of additives, processing aids, but in fact sulfites are widely used. And why this use is so impacted in the wine? Because ECO2 is used from pressing to bottling mostly because of its high antimicrobial and antioxidant activity, but also because it can inhibit enzymes. And once it is a molecule highly reactive, it will react in several mechanisms inside the wine, and it will protect also the wine from secondary flavors and aromas once it can participate in addition reaction and prevent the development of unpleasant aromas. But we need to look further inside the mechanisms that sulfites have inside the wine to understand how they can be so effective. We understand a little bit the mechanisms that are enrolled in the wine quality depletion, but also we need to understand how to control it. So how sulfites act regarding the enzymatic inhibition. Sulfites, in terms of enzymatic inhibition, can block the chemical reaction and revert the quinone back to phenolic compounds. But this is the main mechanism, but also sulfites complex with metallic ions, so avoid and remove the metallic ion that the enzyme requires to do the assimilation of the substrate, the assimilation of the phenolic compounds. And also it will reduce the pH to lower values than those that the enzymes requires to have an optimal activity. So it will reduce the enzyme activity. One of the most important activities of sulfites, it's the antimicrobial. In fact, sulfites are known for its ability to reduce the microbial load of the wine and to control the microbial growth. And it is due mostly to the several mechanisms that sulfite have regarding the control of the cell, the microbial cells. First of all, it has ability to disrupt the proteins through the breaking of the disulfide bonds. This means sulfites can specifically bind in specific place of the molecular chain of the protein and destroy the protein and avoid the cell to feed itself from the substrates. In other way, it can also interrupt the energy production in the microbial cells. It can bind together to the chemical components of the cell wall, modifying the cell permeability, and it will act also with other cellular components. Either the mechanisms together or isolated have result in a microbicidal action, and it will kill the microorganisms. But the other important mechanism in wine depletion is the antioxidant mechanism that protects our wine from the oxidation. In this case, sulfites can act by 3 or 4 mechanisms, but the most important one is the ability to neutralize the hydrogen peroxide that is formed during the oxidation after the formation of the active radicals. And after the formation of the quinones, we still have the formation of hydrogen peroxide, and sulfites is able to react to this compound and inhibit the oxidation phenomenon to move on. But also, in a smaller extent, sulfites can also react with the metallic ions, so avoid. If we reduce the metallic ion content, we will reduce the beginning of the oxidation. And also sulfites, and particularly the molecular form of SO2, it's highly reactive towards the oxygen and can, to a small extent, react with the free and dissolved oxygen present in wine. But we have the other issue related with the consumers' health issues that are mostly related with allergenic effects of sulfites. And several studies are published trying to explain the different reactions of the consumers, the different effects of sulfites at different levels, but all of this information will lead the regulatory entities to change sulfites and include it in the allergen list of the substances in the European Food Safety Agent. The FAO also recommend the reduction of the sulfites ingestion doses uptake, and based on all this information, we are noticing a continuous effort of the regulatory entities to reduce the allowed daily intake doses of sulfites to protect the consumers. Also, the consumers are being much more conscient and concerned about its own health. So they start to look even today to the labeling of the bottles today, and in the future it will be much more marked to understand the chemical composition of the things they are eating and drinking. So they are concerned at a very high level with this type of additives and the effects in the health. But looking to the big picture, we have here a huge question. Sulfites are the devil or the angel, because we need sulfites to protect wine, but sulfites have a huge impact in consumers' health. So how can we solve it? One of the solutions paths, according to the OEV, to the use and to the replacement of sulfites by other additives and other processing aids. Specifically, in this case, we are speaking about oenological tannins. And what are oenological tannins? Nothing more than phenolic compounds with a complex chemical structure generally consisting of a wide variety of monomeric units covalently linked together. They are obtained from different plant species and extracted with solvents authorized by current legislations, and are classified according to the nature of the monomeric units. They can be hydrolysable tannins or condensed tannins. Condensed tannins are the natural tannins present in wine. And according with the chemical composition, we have theoretical properties that are related with oenological properties and functionalities in wine. Tannins have reactivity with proteins, which mean that we can use it as a clarification aid in the case of wine. It's highly reactive with oxygen, acting as a perfect antioxidant in wine. It has ability to chelate metals, so we can use it to reduce the metal content in wine. It polymerizes and form complex, contributing for the color stabilization in wine. It has anti-enzymatic activity, it's so perfect. We can use it as enzymatic inhibitor. And it still have antibacterial activity, so it contributes for the microbial stability of wine and allows us to reduce the sulfite content in wine. These are the functionalities related to the tannin families. But I'm here to speak about chest wine, and chest wine is nothing else than an oenological tannin. And it is a patented tannin by the Polytechnic Institute of Bragança, and is obtained from the byproducts of the chestnut tree, rendering hydrolysable tannins. And the history that Marcio already told you about, the source and the beginning of chest wine, and all the research did by the Polytechnic Institute team and the patent that they gathered. And Three Flowers just start from here. Start from the scientific knowledge generated in the Polytechnic Institute of Bragança and start working the optimization of the extraction process in order to obtain a tannin according and framed by the Enological Codex, which associated with the technological enhanced process that we reach internally yields an extract with unique chemical composition and of outstanding functionalities. And what is, chemically speaking, what is chest wine? Chest wine is a mixture of polyphenolic compounds of complex chemical structure, not simple molecules, not the short phenolic compounds that we have, for instance, in wine, and mainly hydrolysable tannins formed by a wide variety of monomeric units covalently linked. And this unique chemical structure gives chest wine multiple functionalities and also a highly reactive character. These chemical features are responsible for the antioxidant activity of chest wine. And how it works? Okay, it's very easy to understand if we look to this molecule design that we have here. I have the alkyl functional groups associated with a high number of double carbon bonds that are highlighted in the picture. And these groups, chemical groups present in the molecule ensure a strong oxidative capacity, contributing to a high oxygen consumption ability and thus controlling the oxidation. And why chest wine is oenological tannin? We have these classifications per se, because chest wine was perfectly framed inside the OEV mandatory guidelines. So what OEV tells us is for us to classify extract, a vegetable extract, as enological tannin, and specifically hydrolysable tannin, we have to comply with two main parameters that are the phenolic content, the total phenolic content, and the tannin content. And we have specific methods defined by OEV to characterize our product. And the values that we must comply with are 60% in weight of TPC, total phenolic contents, or 20% of tannin content. Either way, any hydrolysable tannin must comply at least with one of these parameters. And in terms of functionality, OEV is clear. For one tannin to be classified as oenological tannin, we must prove the antioxidant activity, firstly, because it's the most important functionality of an oenological tannin. And chest wine acts and hinders the main oxidative mechanisms occurring in wine through two important mechanisms: the free radical scavenging and the metallation. This outstanding capacity is attributed to the chemical architecture of the tannin molecules, which can act simultaneously in both mechanisms. This means the molecular section with higher number of readily accessible OH, that is highlighted in green, is responsible for the free radical capture and act like a radical scavenging, while the metal ion binding occurs near the inner of the molecule, where the proximity of several OH groups generate an electronegative field that attracts metal ions. That is highlighted in the picture in red. So we have values of these properties that we characterized for our product, and we have a SC50. SC50 value represents the concentration of the product required to inhibit 50% of the reactive species, and the activity is as higher as the low is this value. So in this case, from the DPBH method, we have for the free radical scavenging, we have a value of 0.007 milligrams per milliliter. That is quite low. And for metal chelation, we have from the reducing power method a SC50 value of 0.01 milligrams per milliliter. This is a quite potent antioxidant. But also, according to OEV, we need to prove really that our product can consume oxygen. And here we have the oxygen consumption, the OCR method. This means that we put our tannin inside the wine model solution. We supplement this solution with tannin in a 2 grams per liter concentration. And we put these solutions placed inside bottles that are incubated and closed with an oxygen sensor. And we start to take points of the oxygen, the free oxygen value that we have inside these flasks. And we do this test a long time. And When we compare the activity of chest wine, that is the FC represented in the graphics, and we compare the activity of chest wine with the tannin C, that is the green line, and with another hydrolysable tannin, that is GT, we can see that chest wine has, at the end of 10 days, has consumed around three times more oxygen than the other tannins. And here we have our functionality perfectly proved. When compared with other tannins, chest wine, it's 3 times more efficient in consumption-free oxygen. Other important parameter is the coloring properties, because nobody wants to color the wine. We need the opposite. We need that our tannin at least does not impact the wine, and if possible, protect the color of the wine. So an oenological tannin might change the color of the wine to some extent, and according to OEV, we need to measure the coloring index, and we measure for the impact in the yellow and the red colors. And according to OEV, this E index must comply with the following values. We must have less than 1.5% for this value to be considered as a yellow coloring agent, and less than 0.505 for red coloring properties. But chest wine has a coloring index lower than these values. This means chest wine is not a coloring agent and will not impact the color of the wine. So in this image here, we have the color that we measure comparatively with other tannins. C is the wine, the control wine that we used. FC is the wine added of chest wine. GT, the wine added with the other hydrolysable tannin. And TS is the rapeseed tannin. And we have small differences between them for the numeric values, but by eye we cannot see these differences. Proving more functionalities of chest wine, we have the enzymatic inhibition. We did this test for tyrosinases and for lacases. Here we have the data for tyrosinases, where the test was made in grape muscat must, macerated, and supplemented with pectolytic enzymes in a concentration of 4 grams per hectoliter. We did a supplementation with tannin in 10 grams per hectoliter, and we used standard as a standard caphtoric acid. The data gathered in this study was adjusted by Michaelis Menten model, and we reached a final value of tyrosinase inhibition around 50% when we use 10 grams per hectoliter of chest wine. This means that chest wine inhibits tyrosinase enzymes in the must production. But also important is the antibacterial activity. Okay, we know that the state-of-the-art sulfites, we have a strong molecule with a multiple of activities and mechanisms that can lead to microbial action. But we need to check our tannin can in fact be used to in a certain conditions replace sulfites. We need to guarantee that we can control microbial growth in the wine. So what we did was evaluate the minimum inhibitory concentrations of chest wine by the microplate dilution method for acetic acid bacteria, lactic acid bacteria. And we reached a concentration of microbial action or bacterial action around 20 grams per hectoliter for the acetic acid bacteria and 30 grams per hectoliter for lactic acid bacteria. And we are still studying Brettanomyces bruxellensis control because of the importance of this yeast in bottled wine and in the aging of the wine. So by now we still not have the results because this type of yeast is quite difficult to control at laboratorial scale and to grow. And we have been having some issues relating with these tests. So if we compare the action and mainly the antioxidant activity of chest wine and sulfites and look into this strain, I try to simplify the processes because chemically speaking, this is quite confusing. It's a lot of molecules, but we have the train locomotive that is the oxygen it is required to start the oxidation in the presence of the metal ions, iron and copper, through Fenton reactions that will lead to hydrogen peroxide, that will lead also to superoxide radical, that is the most oxidative chemical species that exists, that will attack the phenolic compounds, the ethanol, that will lead to the formation of quinones, aldehydes, and ultimately to acetic acid. So this is our oxidation. But if we use sulfites, we will stop it only after the hydrogen peroxide formation because sulfites acts mostly in blocking this compound and stopping the oxidation here. But the oxidation already started and we generate active radicals that will attack the phenolic compounds. It cannot move on to the acetic acid formation and to the ethanol oxidation, but we already start and generate active chemical species that will start to react with other molecules. But by using chest wine, we can remove one of the three essential factors to avoid oxidation. We will remove oxygen. And if we remove oxygen, we don't have chemical oxidation. Our wine will be more stable without adding synthetic additives, so we will have a more natural wine. So how can we use chest wine? How can we apply chest wine to the wine? So it's quite easy. We try to develop, and we did an internal work very tightly to try to simplify the procedures, not to change the usual procedures of the cellars, and to not to give a new issue for the winemakers. So in this case, chest wine can act as an effective clarifying agent, an enzyme inhibitor, and an antioxidant, and it will increase wine stability and quality during the overall vinification process and along the shelf life. Chest wine can be applied throughout the entire winemaking process, from the pre-fermentation to the maturation, due to its outstanding antioxidant properties, and the specific quantities to be added to the wine depend on both the oenological practice adopted to each wine cellar, and also important, the quality and the sanitary condition of the grapes. But chest wine can also be used in mixed protocols with SO2. This means that producers that want to reduce the SO2 content, but they need another processing aid to stabilize the wine can use chest wine in an effective way. So our application protocol recommends different doses depending on the type of wine. For wort production or pre-fermentation, we have for red wine from 15 to 25 grams per hectoliter. That is the lower doses. For white wines, we require higher doses due to the low phenolic content of the wine. And then we have doses for the malolactic fermentation and for the bottling. And why should you believe in what I'm saying? Because to generate all this information inside Three Flower Solutions, we did our work. We did an incredible work for a startup that is just beginning. We try to prove at the laboratory all the functionalities, but also we want to see if it really works in real context. So to do this, we did the application in a vinification process. And we produced white and red wine in 2022 at a wine cellar close our city, close to Bragança. And we use different chest wine amounts to the wines and compare these wines to the natural and sulfite protected wines. And the wines were periodically analyzed and compared in terms of physicochemical parameters. The Falanca CO index was evaluated in order to understand the effect of the chest wine addition in the phenolic content of the wines. And in this graphic, we can see the phenolic index for the white wine. WW is the white wine, added with SO2, added with chest wine, and the natural without any protection. We did the same for the reds. And what we saw is that the increase of TPC index content is due to the chest wine addition, and it is reflected by this superior value obtained for both type of wines. Both natural wines present lower index compared to the other samples once we have the loss of compounds due to oxidation, and SO2 added wine has a minimal impact once we are not adding any other phenolics, we are just protecting the phenolics from the wine. When you go to the antioxidant capacity of these wines by the DPPH method, once again, the lower value indicates the higher antioxidant activity. As a reference, the chest wine has a EC50 value of 0.007 milligrams per liter. And this means that for the white natural wine, the EC50 is quite high, the bar is quite high. This means that the antioxidant activity is very, very low. Overall, the white wines treated with SO2 and chest wine have higher antioxidant activity because of the impact of both agents in this parameter. The natural red wines have higher antioxidant activity due to their richness in phenolic compounds, but even though the red wine added with chest wine has the highest antioxidant activity, we have the lower bar in this graphic. Among all the tested samples, proving the efficacy of chest wine as an antioxidant agent. And if a client, and sometimes we have these questions from our client is, okay, I'm going to buy chest wine, but for sulfites, I can, in my cellar, quantify the amount of sulfites and program the new doses, reinforcements to protect wine. How can I do it with chest wine? So to answer to our clients, what we do is to develop an internal protocol based in liquid chromatography to quantify the consumption of chest wine during the vinification process. This means that our clients send us samples of the wine at different stages, and knowing the doses that were added at the beginning, we can, and based in this analysis, we can quantify the consumption. This is the analysis of one red wine in this graphic, and here we have highlighting the zone where we can see chest wine. And chest wine can be identified here. And based in our method, we can quantify the decrease of the peak, and so the consumption of chest wine. And we will send back to our client a report with the consumption data and the reinforcement doses that are recommended to guarantee the wine protection. And after bottling, how much time it will last? Okay, we have this question for several times, and we did the same thing. We monitor the chest wine consumption a long time after the bottling. And what we have here in this graphic is time zero, we bottled wine, and then we measure periodically the consumption of the chest wine. And what we see, for example, for red wine, the consumption starts by sharply increasing along the 3 first months due to the neutralization of the free oxygen that was added during the bottling process. But then we have a stabilization drain around 30% of the content added, having a chest wine content related behavior, okay? For different doses, we will have different consumptions, but we see the difference are related with the content that we have. And these protections avoids oxidation and ensures the proper wine stabilization a long time only by using Chestnut. This same wine that we produce nearby was sent for the organoleptic and sensorial properties evaluation via a trained panel at the CVR Trás-os-Montes, that is the regional control board here in our region, and the gathered data was grouped and statistically analyzed. And the main focus was the aroma analysis, the aspect analysis, and the flavor analysis. And overall, what our tasters said to us was that Chest wine boosts the sensory profile of the white wines. The aspect, the wine has higher clarity and deeper yellowness. It develops a fruity and floral aromas and is more acidic, bitter, and thermal flavors. Overall, what they told us from their knowledge was that the recommended doses does not change the aspect, the aroma, or the flavor of white wines when compared with SO2 added wines. And also, most of them prefer the wine added of Chestnut. Either way, for red wine, we have the same test, and what the taster said to us that wine was more prominent clarity, a deeper color, and absence of turbidity. Once this wine was not filtered before bottling, okay, the aroma was more floral, fruity, and balsamic, while slightly develops mineral and spicy aromas, depending on the grape varieties that were and related with that were used in the production. And the flavor, they noticed the higher acidity, a tannin flavor that is related for sure with the presence of Chest wine. Once it is a tannin, the wine has more body and higher thermal sensation. And once again, the tasters preferred the wine added of Chest wine. And where is Chest wine already? We are a small startup, a small company, very young, with almost 5 years of existence. We have this amazing oenological tannin. We start to spread into around the world, and for sure we are most effectively in Europe for one question of proximity, but we are already expanded our markets. We have one trial going on in the United States with very good results. We are also in South America, South Africa, Australia, and we are growing because our product works and is an effective solution for the wine protection during its lifetime. We are also being referred in different publications, social media, and with huge impact because people see and listen to speak about us and contact us for asking for more information and to test our product. So this was what I have to present here. I will need to thank Andrea for the opportunity, and we are now available for answer your questions.
Thank you.
And thank you all for the attention.
Thank you both. We have a question from Benedict. What were the SO2 additions in the mixed SO2 and chest wine additions?
Sorry, I didn't listen well. Can you please repeat it?
So you had a slide where you showed the results where you compared chest wine added to the wine with different other
sulfites.
Yeah, so the question was, what were the SO2 additions? How much SO2 did you add in the treatments that were mixed SO2 and chest wine?
Okay. I think it was around 30 grams per 30 milligrams per liter of sulfites. I need to check that data because I don't have it here, but chest wine was in this. Oh, sorry, I was searching for my protocol. Just a moment. Okay. If it is red wine, we use always the middle value of the interval, okay? So for sulfites, I think it was 30 milligrams per liter. I'm not sure, but I need to confirm that. And for chest wine, we had in the wort production, we had 20 grams per hectoliter.
So for all the trials that you did, because that was one of my questions, for the trials that you did that you presented results on, the additions of chest wine were 20 grams per hectoliter for all of them?
No, we did a screening of doses, okay, because this protocol was generated from dataset. And these values that we are recommending here are based in the best results that we had in our testing, okay? This means that we test higher dose and lower dose than this one that are referred here, but the best results were obtained inside this interval. So we have samples of very different contents of chest wine.
Okay. Okay, any other questions? One question from Robert. When do you expect antimicrobial results? This is a key property also needed to replace SO2, particularly in high pH wines.
Yes, it's true, and he has a point. I can say that at this point, we are already inside 3 hours because we have a continuous scientific work going on. And at this point, we already understand that we need to generate a new batch of product to be more effective in antimicrobial control and microbial control. So we are developing a new batch of chest wine with improved antimicrobial activity.
And you're going to release those results when you get them, I guess, in the next.
Of course, I think we will need more 3 months because now we have Christmas vacations, and for sure, and around March, for sure, we will have concrete results. But the preliminary ones are very satisfactory.
Thank you. I guess an obvious question about this is pricing. What is your pricing look like?
I'm not the recommended person to answer that because for sure I cannot answer that. I don't know it. This is the commercial department can give you this answer, and you can contact us. Our email, let me just. Our email is around here, and you can send us an email, and for sure our commercial department will answer you because I don't know.
Yeah, or on the website.
Yes, here, our contact.
Yeah.
Okay.
For inquiries on pricing, you can go through the website or the email, but it will always be more expensive than sulfites. So it's something natural. It's something that takes considerable amounts of time and production, industrial facilities that makes it not compatible with the price of sulfites. So we're speaking about hundreds of euros. But then we did do a breakdown on the pricing. It would be around per bottle. So the bottle, it will come to about 30 to 50 cents more expensive per bottle. Of course, depending if it's red wine, if it's white wine, and also other particularities. But always much more expensive than sulfites, that we know for a fact. But then if you break it down into the expense per bottle, it will never reach €1 or $1. It will always be in the tens of cents.
Mhm. In terms of application, you mentioned that it can be applied throughout the life of the wine and then it gets consumed. Is that correct?
Yes.
Right.
Yes, yes.
Do you have an estimate throughout the life of the wine, what kind of additions need to be made and kind of what we end up in the final product with, the final concentration? Because we know what to expect for SO2, what to aim for. Also, is there a correlation with pH that you're aware of? Again, especially on the microbial level, you know, we have to add more SO2 as the pH goes up. So is there a similar you know,
Yes.
effect?
Okay. Going step by step.
Mm-hmm.
Here, these doses, this means that if you, depending, let's think in a standard situation, because we have several variables that we cannot control, okay? And it will depend on a lot of factors. But one wine that goes and follows perfectly our protocol, it will require around 2 grams per hectoliter before bottling. And that amount will guarantee the stability of the wine at least for 3 years in bottle.
So that's 2 grams that are added gradually?
No, 2 grams is the last doses. If we had, looking to the protocol, if we had the 15 to 25 grams per hectoliter in the wort production for reds, for example, and 10 to 15 grams per hectoliter in malolactic fermentation, we'll reach bottling with the doses required for 3 years stability from 2 to 5 grams per hectoliter. Okay. And this, from our data, from our sales, we can guarantee the wine stability for 3 years in bottle. Okay. So let's look to the pH. Our product has an acidic character. So if we add it, we will maintain and look into the pH of wine standard value 3.4, 3.5. We have no impact in the wine pH. And further, we need to low down the pH of the wine. We cannot do it by using chest wine, okay? But one important thing is that chest wine will be more effective as the pH goes down. As lower the pH value, as more active will be chest wine. So to lower the pH of the wine, we cannot use chest wine.
No, that wasn't my question. I guess my question, maybe I wasn't clear, is the behavior of chest wine similar to SO2 in the sense that the higher the pH you have in your wine, the more SO2 you need to add to maintain microbial stability, because you know how.
Yes, for sure.
On that.
For sure. Sorry, I didn't understand that. My fault. Yes, for sure. Because when we hydrolyze chest, let's go back. Chest wine is an hydrolysable tannin. This means that at specific pH values, it will start to decompose effectively. But this is under acidic conditions. As lower the pH, as more effective is the dissociation of the tannin molecules, and more effective and increased functionalities we will have a long time. If we go to higher pH, we are required to add more chest wine to guarantee the same effect.
Mm-hmm. Yeah, that was my question.
It's the same thing. Mm-hmm. It's the same thing. Okay.
Thank you. And in terms of inhibiting malolactic fermentation, that's something that interests me in particular. I'm actually looking at various inhibitors right now. Would you say that I see some recommendations here right on this slide? Is that a one-time addition, or should it be added throughout the life of the wine?
This is just, these doses are only to protect the wine during the malolactic fermentation. We cannot inhibit malolactics with chest wine. Okay. We cannot inhibit it. We already tried to do it, but we can only delay it. We will have a bacteriostatic effect, not a bactericidal. So we can inhibit malolactics using chest wine.
Okay, Thank you.
To whites, this is an issue, but it's the truth. Okay.
No, I appreciate that. It's good to know. Yeah, thank you. I don't see any.
But Andrea, just for further information about this, we are developing and also testing and doing some studies, try to develop solutions for inhibition of malolactics using chest wine mixed with other additives. So I think there's some things that are being quite promising, including some type of acids that can be added and have a true impact in inhibiting malolactics.
Like
Mixed
fumaric
with chest
acid.
wine,
Yeah.
for instance.
Yeah. And I think you mentioned something about color stability. Would you mind going back to that?
Yes, for sure. Okay. So we have different mechanisms enrolled when considering the color, the wine color depletion. And for sure, sulfites have a negative impact in the wine color because it will remove anthocyanins. Okay. Chest wine protects the anthocyanins from the oxidation, does not have the same impact of sulfites, and also it has an important, I don't have here that results because it will be a huge presentation for a long time and it will be quite boring. But we have some tests that shows that chest wine contributes for the color stabilization in the wine, mostly in reds, but not. It's different, a different mechanism from the condensed tannins. Condensed tannins from the grapeseed, for instance, has a particular capacity for a chemical polymerization and to bind directly with anthocyanins. In our case, it's not like that. We protect the anthocyanins because we avoid their oxidation. It's like an indirect protection. Okay?
I see.
But it's effective.
And I have one last question. So I had so many questions.
Don't worry.
Oh, I have one last question about the sensory part of your trial. So for the sensory results that you presented, do you happen to know what concentration that was at of chest wine?
Chest wine is again, I don't have that value here because I need to check the report, but for sure, and for sure, is inside these values.
Okay.
Because everything was framed depending on the results of that assay. And to be truly effective, we need to have a transversal result that guarantees this condition works and we have each point covered by our results.
Okay, thank you. Those were all the questions that I had, so thank you very much.
Okay, thank you very much for your interest. I hope you have enjoyed it.
Yeah.
And it was a huge pleasure. Okay. And
Likewise.
If you want any further information, our emails, mine and Marcio's, are here. For commercial proposals, general email will be effective, but even if you send us something, we can always follow up for our commercial department.
Thank you so much. And thank you all for attending this webinar. If you're still here, please don't forget to fill out the survey that'll pop up once I end this seminar. So thank you, everyone. I hope you have a wonderful day and a wonderful holiday season. And I'll see you in the next year, the new year.
Thank you.
Goodbye, everyone.